in your domain, so you're fine. And then the next thing you do is you draw a chart like this. Now, using these 3 points, I'm going to split the domain into several parts. And so you should have, it's going to be, you should have negative infinity to -3, and then -3, -3 to -√3, -√3 to let's see, 0, and then 0, 0 to √3, √3 to 0, I'm sorry, √3 to 3, and then 3, and then 3 to infinity. Let me say this again. So if you want to check where is it increasing and decreasing and which one is local max and local min, you should draw a chart like this, and then you should use the critical points 0, -3, and 3 to split your domain into several parts like this. And this guy would be so this guy would be the points where the derivative is 0. So 0 here. And I only care about where is it, whether it's positive here or negative here. I'll let you check, but you can check that this is positive. Let's see. And this is negative, this is negative, and you can also check that this is negative, negative, and positive. So how do I check that? So for example, for this interval, you pick a number in between -infinity to -3, and then plug that into your derivative here. You get positive. And do the same thing for other intervals. If the derivative is positive, that means the original function is increasing. And minus means decreasing, 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 decreasing. You have a plus here, so it's increasing. So that means this point, -3, is your local max. So local max, it happens at x equals -3. I'll let you check the y value. So to get the y value, you simply need to put -3 into the original function. If you do that, you get -9/2. Local min, you only have one local min, which is 3. Again, if you put into the original function, you should get 9/2. What about this point? So it's it's decreasing on the left, it's decreasing on the right. That means it's nothing. It's not a local max, and it's also it's not a local min either. And then you can write down what is the increasing and decreasing interval. So the function is increasing on -infinity to -3, union 3 to infinity. It's decreasing on these 4 intervals. So you have -3 to -√3, union -√3 to 0, 0 to root 3, root 3 to 3. So local max, local min, increasing and decreasing. We're not done yet. The next part is to look for inflection points. So I mentioned in the beginning that the second derivative is this guy. So let me write this down again. This is the fifth. So second derivative equals that. Okay, so if we want to find out what are the inflection points, we have to look at the second derivative. And how do we use the second derivative to find out what are the inflection points? You look at all the points where the second derivative is either 0 or undefined. Well, I'm going to ask the same question again. What are the points? So at what points is the second derivative undefined? If you say again plus or minus root 3, then you're wrong. Notice that the domain doesn't have root 3 and root 3 and negative root 3. So the second derivative is never undefined. That means I only need to look at the points where the second derivative is 0. But then the only way for a fraction to be 0 is the top is 0. So I have 6x times x squared plus 9 equals 0. You have two things multiplied to be 0. That means you have x equals 0 or x squared plus 9 equals 0. This guy, x squared equals negative 9. Does it have any solutions? No. So x squared, there's no way a number square would be a negative number, right? So whatever numbers you put in here would always be positive. So this has no solution. That means the only candidate for the inflection points is x equals 0. And now what do we do? Oh, I should probably say that we are trying to figure out where is it concave up, concave down, and where are the inflection points. Okay, so this is the only point, this is the only candidate for inflection points. Now you need to check both sides using the second derivative. Again, draw a table like this. Now this time you're using the second derivative. You only have one point, so use that to split the domain. You should get this. Again, so this should be a point where the second derivative is 0 because you found that to be 0. Now on each of these intervals, pick a number in between and plug that into a second derivative. I'll let you check, but this one should be negative, this one should be positive, this one should be negative, this one should be positive. So it's concave down here, concave up here, concave down here, and concave up here. Well, remember that second derivative negative means that the original function is concave down. Second derivative positive means that it's concave up. Again, negative concave down, positive up. Okay, now you can write down. Okay, so what can we say about this point? So to the left of this point, it's concave up. To the right of this point, it's concave down, which means this point is an inflection point. And it's the only inflection point. And then you can also say that it's concave up on this and this. It's concave up. Sorry, concave up on this and concave down on this too. Are we done yet? Nope. The last step is to sketch the graph, which is the craziest part. Okay. I'm going to do this properly. All right, so remember that, let me show you. Okay, so remember that the domain is everything but plus or minus root 3. So I'm gonna exclude negative root 3 and positive root 3. I also have vertical asymptotes at root 3 and negative root 3. So vertical asymptote is like this. Right? I hope it makes sense. So these are the only two vertical asymptotes we have. What else do we have? We also have, well, we don't have any horizontal asymptotes because those are plus or minus infinity. But we have another asymptote that's called the sine asymptote, which is y equals x. What does it look like? It's actually a diagonal line like this. Okay, let me draw this carefully. Okay, so I'm drawing y equals x. Okay, and now I'm gonna figure out, I'm gonna put in what are the local max and min. So if you go back to your computations, you see that local max happens at negative 3 and the y value is negative 9 over 2. Okay, so negative 3 is somewhere here. And negative 9 over 2 should be here. So this would be a local max. If it's a local max, it should look like this, right? So I'm gonna draw like this and leave it like this for the moment. And what else do we have? We have a local min. Local min happens when x equals 3 and y equals 9 over 2. So 3 is somewhere here. So that. And around that point, because it's a local min, it should be a U shape like this around this point. So let's leave it like this for now. What else do we have? Okay, let's see. So let's look at the increasing and decreasing. So it's increasing on from negative infinity to negative 3. This is negative 3 right here. So that means before negative 3, the function is increasing. And so I can carry on and draw like this. And because y equals x is a slant asymptote, this graph should approach this line when x approaches negative infinity. And I also know that between negative 3 and negative root 3, it's decreasing. So negative 3 and negative root 3, it's decreasing. That means I need to draw like this. Again, this is your vertical asymptote, so that means the graph would approach this one, this line. Now do the same thing here. So this is increasing. This is increasing. Sorry, this is decreasing. This is increasing. And yeah, so it gets closer and closer to that slant asymptote. And then on this side, it gets closer and closer to this vertical asymptote. What happens in the middle? We need to look at the increasing interval and also concave up and down. So between which is where is it? Between root 3, negative root 3 and 0, it should be decreasing, right? And we also know that the origin is the what is it? The origin is the x and y intercept, which means it's on the graph. So this is decreasing from negative root 3 to 0, which means the function, well, it could either look like this or this, but which one is it? This is where you need to concave up and down. So from negative root 3 to 0, it's concave up. So it has to be this. Let me say this again. I know that this is decreasing, right? So it's either like this or this. It's a U-shape opening upward or U-shape opening downward. To see which one is which, I look at the concave up and concave down. Because it's concave up here, so it will look like this. Again, it should approach the vertical asymptote. The same thing here. So between 0 and root 3, I know that it's decreasing. I also know that it's concave down. So decreasing plus concave down, which means it has to look like this. And approaching, again, the vertical asymptote. And this is the graph. Alright, that's it for today. Sorry for going over time, and we'll talk about more examples and more by work problems on Friday. See you guys. Peace.